Alright guys, my name is Daniel. I'm going to be showing you how to identify a conjugate base. So the question we have here is identify the conjugate base of acetic acid in the reaction. Okay, so we have acetic acid and bisulfate reacting to produce sulfuric acid and acetate ion. Okay, so the first thing you do here, well, if you haven't, if the question doesn't write out the reaction for you, is to, or it probably will, but anyways, if it doesn't give it to you, you should probably write out the reaction first. That's the most important thing. Okay. Now the next step is to define what an acid and a base is. Okay. So if you could recall from Gen Chem 1, an acid is, or at least the Bronsted definition of an acid is a proton donor. Okay. Something that's going to be donating a proton inside a reaction to produce a base on the opposite side. And a proton or Bronsted base is something that's going to be accepting the proton to produce an acid on the opposite side. Okay, so let's get to it. So let's look at acetic acid right here. Okay, in the name acetic acid, it's kind of a dead giveaway, but let's say you're looking at it and you don't recognize that it's an acid. Okay, so the way you determine that this is an acid is that if you look at the opposite side, you see something that kind of looks like it. Alright, do you notice it? I hope you can notice the similarity. The only difference between the two is this has a hydrogen at the end, making it an acid, and this over here is just an ion. Okay, so we need to identify everything. Okay, so since this has acetic acid, we can already label this our acid. Okay, now we look at this right here. Obviously it's going to be our base since it's the only thing remaining, but let's say it was another ion here, or another acid right here that wasn't such of a dead giveaway. Okay, the way you can identify that bisulfate is your base is that if you look at the opposite side, it's gaining a proton. You see how right here bisulfate has a negative charge. On the opposite side, it has no charge. It's neutral. It's sulfuric acid. Okay, so we can label bisulfate as our base. All right. Now we need to identify what a conjugate base and a conjugate acid is. As I previously mentioned, right here you have acetic acid. When it reacts with bisulfate to produce these two products, you can see that this acetic acid will donate its proton to bisulfate to form both sulfuric acid and acetate. Okay. Now, which one of these is a conjugate base? The conjugate base is pretty much going to be whatever is on the opposite side of the reaction that pretty much looks the most like this side. Okay. It's kind of hard to really define it, but that's basically what it is. Okay, so you see here that acetic acid donates a proton to leave itself with a negative charge, because right here it's neutral, has a zero charge. Okay, but if you donate a proton to become more negative, you end up with an ion. Okay, so we can identify this as our conjugate base. Now I know that we've already answered the question, but I like to just go on to explain a little bit more concepts, a few more concepts. All right. Now if you look at your base right here, bisulfate, it accepts a proton from acetic acid to form sulfuric acid. Okay, so that's going to be your conjugate acid. Okay, now you pair this acid with this conjugate base, and this base with this conjugate acid. Alright, and what you're basically labeling here, or identifying, is that let's say you flip this equation around. Alright, now let's do that. Alright, so we have sulfuric acid plus acetate ion reacting to form acetic acid, and bisulfate. Alright, now let me switch colors. Now on this side of the equation, you see it's exactly the same thing as this one. It's just flipped around. Okay, but if you're looking, if the problem gave you this reaction, then this would become your acid, this would become your base, and as you can see from this reaction, we just pretty much changed the name. Okay, so acetic acid right here becomes the conjugate acid over here, and this becomes a conjugate base. Okay, so basically the way to identify what a conjugate base is that it has to be on the opposite side. Okay, you can't have a conjugate acid or a conjugate base on the reactant side. Okay, because in this equation we're observing it going that way, but if we are observing the same equation go the other way, this way as written here, then all of a sudden you're seeing sulfuric acid and acetate becoming your acid and your base, respectively. Okay. Now keep in mind that acetate isn't actually a base. It just acts like a base. Okay. It's not actually identified as a base. If you look up bases, acetate won't come up. Okay. It's just that in this situation, acetate's going to accept a proton, the definition of a Bronson base, to become acetic acid. Okay. And the same thing goes right here. Sulfuric acid will donate a proton to acetate for sulfuric acid to later become bisulfate. Okay. Now I hope I explained everything pretty well. I hope you understand that. And if you have any questions, of course, ask your professor or your peer leader or something. So we can identify that this right here is our conjugate base. Thanks for watching, and I hope you enjoyed.